My hope is that after you go through this section, you'll have a profile picture that you'll see on many websites, including GitHub. When you inevitably need to change the picture, you can do it once and it'll take everywhere. Perhaps more importantly, what we're covering here provides you some core knowledge people need to understand in today's technical world. Being able to properly give names to parts of Git enables you to get better technical service and will result in less confusion on your part. On GitHub repos, the icon at the upper right corner, you can click like a menu button. Click on it for a drop-down menu. If you see a generated icon instead of your picture, you can of course click Upload New Picture and supply a file from your laptop. But I would like to take this opportunity to illustrate an important technique that Git and GitHub uses. A technique similar to the way Gravatar associates your email address with your picture, such that GitHub and other sites can display your picture automatically without you having to supply your picture to every website. We'll define a gravatar on the website gravatar.com. Gravatar is a contraction of the G in global, the R from recognized, and avatar, a word meaning a graphic that represents someone, like a logo for a company. Click Sign On. We're forced to create a WordPress account because the many WordPress websites make extensive use of the Gravatar service and so use WordPress credentials to save millions of people the trouble of creating another account. When GitHub or other websites want your picture, but the email address is not directly specified in the URL. Instead, the URL address looks like this to reach a Gravatar picture. The last part specifies a picture of 80 pixels wide. The string to its left is what's called a hash generated according to an algorithm publicly defined here by the name of Message Digest Algorithm Number 5, or MD5 for short. The Gravatar website applies the algorithm mathematics to generate a hash based upon the email address. Because the algorithm is publicly defined, another website can generate the same hash result when it uses the same content as input. By the way, computer people refer to this hash as 128 bits. This is because each of the 32 digits represents binary ones and zeros. In binary arithmetic, the value of a 1 in each position doubles as we count right to left, from 1 to 2 to 4 to 8 to 16, etc. In the examples, the value 8 has a 1 in the position worth 8, and 9 also has a value of 1 added from the first position. A 1 in the 128th bit at the far left would have a very large value and a lot of digits if we used our normal decimal notation of 0 through 9. To save space, we chop up the 128 bits into 4 bits at a time. Various arrangements of 4 bits can have 16 combinations of value, which is what each hexadecimal digit represents, since it extends the decimal alphabet from 0 to 9 to also use A through F for values 11 through 15, with 0 counting as the 16th number. Anyway, I bring this up because Git uses a similar hashing mechanism, but with several differences. The hash that Git generates has 160 bits because Git uses a different hash algorithm, the SHA, or Secure Hash Algorithm version 1. Normally, hashes are used only for one-way generation, as a short digest of a file to tell if the file was altered during transmission. One cannot take a hash and turn it back into the content used as the basis for the hash. However, Git uses utilities which store data in a way that does retrieve file contents back from a hash. It works by using the 40-digit hash as the name of the file containing content. This is also why Git is called a content addressable file system, because the content hash also provides a way to obtain the address back to the content rather than using traditional sequential indexes that SQL databases generate. The files are stored in the objects folder within the Git repository. The first 2 characters of each hash file name is used as a folder name to partition files so that all files are not within a single folder. These 2 Git commands, Git documentation classifies as plumbing type internal low-level commands most Git users rarely type out. The user-friendly equivalent are called porcelain type commands people use every day, such as git add, which is probably the most used of all Git commands because it puts each version of text under Git control. The command extracts text from files specified in the command. A dot instead of a specific file name specifies all files in the folder. The -p pauses so you can manually choose what to do with individual hunks changed within a file. Git calls the text content it stores in files blobs because Git doesn't add just plain text into files. Just so no one forgets this fact, Git adds the word blob in the content it actually hashes. Text added also contains a count of characters, in this case 10, a null character, and the new line special character at the end of the string. To save disk space and faster retrieval speed, the whole string is stored after being compressed using the zlib utility. So that we don't have to type out the entire 40 digits of a long hash address, Git provides a way for us to type only the first few digits by having its various commands make an internal call to a plumbing command that looks up the full hash. At this point, the add operation is not quite done. The contents within files are in content blobs, but what about the names of files such as README? The git add command also creates for each file added an entry in an index file within the repository. The commonly used git status command reads from this file. There is also a plumbing command to display all the files in the stage area. It lists one entry for each file Git has added for tracking. Each entry contains the file name of the original content next to the file's content hash. Next to that is the Linux-style security permission settings for the group, and for 644 means file read-write. A limited amount of documentation about index file internals reveal there are flags about the status of each file tracked that are not shown in output from Git commands. The format of data inside the index file is binary and not plain text, so some have tried special commands in some text editors or a hexdump program to examine its contents. Now, if we add a second file containing more text, the hash of that blob is added to the list. What is important here is that when a git commit command is requested, it internally issues a command to create a new tree type object file in the repository. A tree's hash gives git commands a way to access all text in blobs referenced by that tree. Git commit stores several pieces of information in its hash content. The command is issued with a message provided as a parameter. The content used to generate commit objects include that message text, but also the name and address of the author and committer, along with date and timestamps that are familiar to Nix developers. The timestamp numbers are the number of seconds since January 1st, 1970, and the time zone offset for the local machine. These are converted to human-readable dates by git log and other commands that read the hashes generated for each commit. Git log and other commands can follow the sequence of commits because commit content contains a reference to its previous commit made. This linkage automatically occurs when the previous commit hash address is specified in the internal operations that git commit processes. To recap, hashes are used as the file names for all three types of objects that Git stores in its version-controlled repository. Within blobs are the content of text in files tracked using the git add command. We reveal the status of files tracked in the index file using the git status command. Invoking a git commit locks the current status into a tree object referenced by a commit object. The chain of commits is listed using a git log command. Individual commits can be referenced by a short address, and a specific commit can be permanently associated with text specified in a tag command. For another insight, let's take a look at a diagram of another set of examples from the Git book. This diagram presents the three types of objects and the chain of commits to make the point that when text within a file has not changed, Git can just reuse a pointer to it rather than duplicating the content and thus taking more space. Next, time for a little quiz. Although we don't have time today to discuss the answers, I look forward to seeing you in my class.